In this module, we will talk about DRS, the Distributed Resource Scheduler. And we will see that DRS is one of the most advanced features of vSphere. And when they talk about vSphere being agile, they're talking about DRS. So in this module, we will talk about load balancing across ESXi hosts. We will do a review of vMotion. We will see that DRS is simply automated vMotion. We will configure DRS, examine load distribution, and configure affinity rules. As we discussed in the previous module, we saw that a cluster is a group of hosts. And a cluster can be used for high availability, as we did in the last module, or a cluster can be used for DRS. DRS, the Distributed Resource Scheduler, balances the workload across ESXi hosts. In other words, if you have one ESXi host, which is hardly doing any work at all, it's at 10% utilization, and you get another ESXi host, which is heavily loaded, it's at 90% utilization, DRS can move the virtual machines from the more busy ESXi host to the less busy ESXi host for the purpose of load balancing. DRS is simply vMotion automated. So let's do a review of vMotion. vMotion allows us to move a running virtual machine from one ESXi host to another ESXi host without having to shut down, without having to cut the users off. The users remain connected the whole time. vMotion allows us to move a running virtual machine from one ESXi host to the other. So here's the example. We got 3 ESXi hosts. One of them is running at 100% capacity. The other 2 are running at 25% capacity. We can use vMotion to move these virtual machines from the more busy ESXi host to the less busy ESXi host to load balance those ESXi hosts. So now they're all operating at 50% capacity instead of one at 100% capacity and the other 2 at 25% capacity. DRS, the Distributed Resource Scheduler, automatically does this process. It automatically moves virtual machines from more busy ESXi hosts to less busy ESXi hosts. So let's create a DRS cluster, configure the cluster, add hosts to the cluster, and then verify that the cluster is load balanced. First, we log on to the vCenter server, and I will go to our data center, right-click, and select New Cluster, and I will name the cluster Cluster 2. In the previous module, we selected vSphere High Availability. In this module, we will turn on vSphere Distributed Resource Scheduler. And what this does is it migrates virtual machines from more busy ESXi hosts to less busy ESXi hosts. Click on Next. I could click on Manual Mode, in which case it doesn't migrate the VMs, or I can select Partially Automated. Now with Partially Automated, when a virtual machine comes up, it's loaded on the least busy ESXi host. But with fully automated, virtual machines are moved while they are running from one ESXi host to the other to achieve load balancing among the ESXi hosts. With fully automated, it moves the ESXi hosts from more busy the virtual machines from more busy ESXi hosts to less busy hosts to achieve load balancing. The DRS migration threshold can be set to conservative or aggressive, And conservative means it's not going to start migrating the VMs from one host to another unless there's a big difference between the two. So if one ESXi host is operating at 90% capacity and one is operating at 10% capacity, it'll definitely migrate the VMs from one to the other. However, if one host is operating at 60% capacity and the other is operating at 70% capacity, it's not. Now, with aggressive mode, then what it's going to do is it will migrate virtual machines from one host to the other, even if there's a slight difference between the two ESXi hosts. So if one is running at 60% capacity and one is running at 70% capacity, it'll still move the virtual machines between the hosts to try to achieve the middle ground, which would be 65% capacity. We will leave it at more conservative. Now, why not leave it at aggressive? Well, the problem with this, if it moves virtual machines around too much, just the process of migrating virtual machines takes up more network infrastructure resources. So we typically leave it at conservative, meaning it's not going to migrate virtual machines from one host to the other unless there will be a significant improvement in the cluster's load balance. Click on Next. Power management. Distributor power management uses wake on LAN. And what that means is if we enable it, or if we select automated mode, what it'll do, wake on LAN means that vCenter and DRS can remotely turn on or turn off an ESXi host for purposes of power saving. So if we enable automatic DRS power management, what it means is if there is an ESXi host which is hardly doing any work at all, then that ESXi host will be, then the virtual machines running on that ESXi host will be moved to another ESXi host, and that ESXi host will be shut down to save power. We typically set it to conservative, and that means it's only going to shut down an ESXi host if a lot of power is going to be saved. Click on. We could set it to aggressive, but we will leave it on conservative. Enhanced vMotion compatibility. Now, all of the ESXi hosts have to have the same type of microprocessor. Either they got to all be AMD or they got to be all Intel. And if they're all Intel, ideally they're identical Intel processors. If they're not all Intel processors, then they will all be set at the functionality level of the lowest functioning Intel processor. So if you have many types of Intel processors, the lowest functional level of the Intel processor is the Meron generation of Intel processors. And if I select that, then all of the ESXi hosts, even with higher functioning microprocessors, all those processors will function at the level of the lowest functioning processor. This is called enhanced vMotion compatibility. All of the ESXi hosts have to either be all AMD or all Intel. If they're Intel, it does support different types of processors. The swap file is typically installed in the same directory as the virtual machine. The only reason that you wouldn't do that was you thought there was going to be a lot of swapping, a lot of paging, and you might want to move the swap file to a higher speed data store, but typically not, because that would assume that we were short on RAM, and let's hope that we're not. Click on Next, and then it creates the cluster. We click on Finish, and now we have created a new empty cluster, which has no hosts in it, and now we have to add hosts to the cluster. So now let's add hosts to the cluster. To add a host to the cluster, we right-click on the cluster, select Add Host, and this looks just like adding a host to vCenter Server, which we did in Module 4. We type in the IP address of the host, the username of the host, which is usually root, and the password. We click on Next. It shows us the secure hash algorithm, which is the same number that we saw when we installed the ESXi host. We click on Yes. It shows the virtual machines which are running on that ESXi host. We click on Next. We will type in the license key later. Next. We will not enable lockdown mode. Next. We will click on Finish. Across the bottom, we can see the status is that the host is being added, and now the host has been added to the cluster, and there's the host and the virtual machines that are on that host. Let's add another host. Right-click, select Add Host, type in the IP address of the host, and the username, and the password, followed by Next. We will type in the license key later. We will not enable lockdown mode. Click on Finish. It says it's adding, and now we have added 2 hosts to the cluster, and of course you must have a minimum of 2 hosts in a cluster, otherwise it's not a cluster. So I have added 3 more hosts to the cluster, and now we can see we have a total of 5 hosts in the cluster. So we've created the cluster, we've added hosts. Let's now look at the cluster properties. If we look under Summary, we can see Distributed Resource Scheduler is on. Our total resource, we can see our total CPU resources, our total amount of memory, that there are 5 hosts and 20 virtual machines. Under DRS, we can see that it is fully automated to move virtual machines from more busy ESXi hosts to less busy ESXi hosts. And right now it shows that it is currently load balanced. We have a green checkbox that shows it is currently load balanced. If it wasn't currently load balanced, we would see an error message right here. If we look under virtual machines, it shows the virtual machines that are running and which ESXi host each virtual machine is running on. This shows our 5 hosts and how hard each host is working. The DRS tab shows that we are using fully automated DRS, meaning that DRS will automatically migrate virtual machines from more busy hosts to less busy hosts. If we click on the Performance tab, we get overall performance for not a single host, but for the cluster as a whole, for all hosts. So we can see the available CPU and CPU utilization, and you can see that the total CPU utilization is the total CPU available is the blue line above, and the total CPU utilization is the orange line down here. So you can see we're only using about less than 10% of the CPU resources, the entire cluster. And under memory, we can see that we're using about half to 2/3 of our memory is being used. So this shows that this cluster is not working very hard. It doesn't show that it's load balanced, it just shows that it's not working hard. It is load balanced, but that's not what this shows. If we click under Maps and we zoom in, it gives us a nice graphical representation, because sometimes it's hard to keep track of which virtual machine goes with which host, and Maps gives us a good graphical representation of the relationship between the virtual machines and the hosts. If I go back to the Summary tab, the most important thing I want to point out is that this cluster is balanced. We see the cluster is load balanced because it is configured to be fully automated. You can configure, we just showed how you can configure DRS to be fully automated. That's a good way to go. However, you can also configure DRS to be partially automated. Recall that when we initially configured it, we saw that one option was to use partially automated. With partially automated, when a virtual machine initially starts up, it is loaded on the least busy ESXi host. However, only with fully automated are virtual machines moved from one ESXi host to the other after they're up and running for purposes of load balancing. With partially automated, it gives you suggestions as to what you might do if the cluster is out of balance. So let's take a look at that. If the cluster is imbalanced, the administrator is notified, and then the administrator has to manually implement DRS. So let's examine load distribution and see if we can identify an imbalance. If we look under the cluster, under the summary tab, we can see that here's an error message that indicates that there is a load imbalance. How come there's a load imbalance? Because automated migration is not enabled. If we select the View Resource Distribution chart, we can see that one host seems to be doing all the work and the other four aren't doing anything. That's CPU utilization. If we look at memory utilization, it looks like 2 of the hosts are doing all the work and 3 of the hosts aren't doing anything. And the reason that is so is because we don't have automated level turned on. If you look at the DRS tab, we have partially automated enabled. And what that means is it provides DRS recommendations. And for you to implement those recommendations, you can click on Apply Recommendations. And if you had selected fully automated, then you wouldn't need to click on Apply Recommendations. But when you select partially automated, it gives you the recommendations and doesn't implement them unless you select Apply Recommendations. DRS provides load balancing. It distributes the load across ESXi hosts. It can be configured manually, or it can be configured to automatically distribute the load across ESXi hosts. Let's now move on to affinity rules. Affinity means two things go together. Like, I have an affinity for chocolate. There are VM to VM affinity rules and VM to host affinity rules. VM to VM affinity rules keep certain VMs together or apart. And VM to host affinity rules place certain VMs on certain hosts. VM to VM, so let's start out by looking at VM to VM affinity rules. Two different examples. One, we want to keep certain VMs running on the same host for purposes of fast communication, such as an application server and a database server, because if they're running on the same physical machine, they're going to communicate faster. Or we want certain virtual machines to run on different ESXi hosts for purposes of fault tolerance, such as domain controllers. So let's create affinity rules. Affinity rules which will keep VMs together or keep VMs separate, anti-affinity rules. We go to our cluster, we right-click, and under Cluster Settings, Under rules, there are no rules. I will click on add, and I will give this rule a name. I will call it app and database server, and the type of rule will be to keep the virtual machines together. I will select add. I will select the application server and the database server because I want to keep them running on the same host, and I will click on OK and OK. And then I will click on add again to put the domain controllers on different hosts. I will call this rule domain controllers, and the type of rule will be to separate the virtual machines. I will click on add. I will add both domain controllers followed by OK and OK. Two VM to VM rules. We can have VM to VM rules that keep the VMs on the same host or that keep the VMs on different hosts. These are VM to VM affinity rules. Now, let's look at VM to host affinity rules. VM to host affinity rules is where we want certain VMs to run on certain hosts. For example, we want virtual machines, which are domain controllers, to run on powerful hosts. So what we do is we create DRS groups. If we want domain controllers to run on high-end hosts, we create two DRS groups. The domain controllers groups and the high-end host groups, and we link those together with an affinity rule. The rules we can specify are that these hosts should, VMs and hosts should run together, or that they should not run together, or that they must run together, or they must not run together. These are what we call required or preferential VM to host affinity rules. Let's look at these two rules. Preferential is where I would prefer that this group of virtual machines gets run on one of these ESXi hosts, and that these virtual machines run on these ESXi hosts. But if these ESXi hosts crash, well, then that's okay. We can have the virtual machines run on the other ESXi hosts. That's preferential. Now, required is whereby we specify that these virtual machines run on these ESXi hosts, these virtual machines run on these ESXi hosts. And if the hosts crash, then these virtual machines are not going to get loaded up. And the reason we do that is for purposes of host licensing, where certain pieces of software are licensed to run on hosts which have a specific number of processors. We have required rules or preferential rules. We usually go for the preferential rules. So let's create a VM to host affinity rule using DRS groups, domain controller groups, and the high-end host groups. In cluster settings, we select DRS Groups Manager and we click on Add. And I will add Domain Controller 1 and Domain Controller 2 to a group, and I will call that group Domain Controllers, and that would be a virtual machine group. And then a hosts group, if I click on Add, would include the high-end hosts, followed by OK. So now I've got a group of virtual machines, which are the domain controllers, and a group of the high-end hosts. Now I go down to rules. I will click on Add, and I will see I've got a domain controllers group, and I've got a hosts 1 group. And the rule, which I will call domain controllers on hosts rule, will be a virtual machine to hosts rule. And the virtual machine group will be domain controllers, and the host group will be host group 1, and the rule will not be must run, it will be should run. That's a preferential rule. I like it that way, but if it won't, I can still live with it. Click on OK. So we have 3 separate rules set up. Affinity rules can be VM to VM rules, which will keep certain VMs together or apart, or VM to host rules, which place certain VMs on certain hosts. EVC Enhanced Virtualization Compatibility Cluster Requirements are that all of the hosts in the cluster have CPUs from the same vendor. They're either all Intel or they're all AMD. And if they are Intel, it's got to be a minimum of a Core 2 or better. If they got to be AMD, it's got to be an Operon or better. It's got to be a 3.5, ESXi 3.5. Has to be connected to a vCenter server. It should be enabled for hardware virtualization. The BIOS should be enabled for execution disable technology. So you go to the BIOS and you enable what AMD calls no execute and what Intel calls execute disable. I know that sounds funny. You go to the BIOS and you enable the execute disable. The system should be configured for vMotion, and the application shouldn't crash a lot, because if they do, it'll trigger migration from one host to another. Common DRS problems. Common DRS problems are either one, that the resource limit is too restrictive, that a cluster is overloaded, or a host is overloaded. If a resource limit is too restricted, remember we talked about setting client reservations, about setting VM reservations. If the VM reservations are too restrictive, then certain virtual machines may not load up on certain ESXi hosts. The cluster might be overloaded, which means you need another ESXi host in the cluster. You have too many virtual machines or not enough ESXi hosts. If the cluster is overloaded, get more hosts. And if a host is overloaded, then you could upgrade the host by getting an additional blade. If we go to pubs.vmware.com, we will see there's a section on creating a DRS cluster, which explains load balancing and power management. It explains affinity rules, VM to host and VM to VM. And it also explains that tricky concept of the migration threshold, whereby conservative says it's only going to migrate VMs if there's a big difference between two ESXi hosts, and more aggressive, which says it'll migrate VMs even if there's only a little difference between ESXi hosts. In summary, we've talked about load balancing across ESXi hosts. We reviewed vMotion, and we saw that DRS is simply automated vMotion. We configured DRS, and we examined load distribution, and lastly, we configured affinity rules. This concludes Module 12, Scalability and Load Balancing. Thank you very much, and have a nice day.